I'm going to show you guys how we can work out this double integral right here. And unfortunately, if we integrate cosine of y to the third power into y rho, that's not going to work. We do not have an antiderivative for this. So we actually have to change the order of integration. That's the way to go. And to do so, we have to pay attention to the limits of integration, specifically that region, and let's take a look right here. So of course, we have the y-axis and also the x-axis. We are in the y world first. Pay attention to this right here. Look at y equals square root of x. That is just our goal curve like this. And let me just put this down right here for you guys. And then we go to 1. So we have this curve and then we go up. Y is equal to 1. It's somewhat like this. So this is y equals 1. And then we look at the x, which is going from 0 to 1. So that's nice. It's just from here to here. Right here is x equals 0. And then, in fact, when x is equal to 1, y is equal to 1. So it's just this little region here. All right. Okay, then what do we do next, though? We'll change order, right? So that means we want the red integral be on the outside, and then the integral in terms of the x on the inside. And of course, we still have cosine of y to the third power, but we really want the dx coming first and then dy next. Now, the hardest part, of course, to figure this out. This is how we do it. Originally, when we have y, right, going from this to that, we look at a vertical rectangle. But now, if you want to change order, we actually look at a horizontal rectangle instead. So this is kind of like when we were in Calc 1 and we do the area between curves. We can draw the rectangle vertically or horizontally. If x goes first, we put the rectangle horizontally. So let's see. We want to look at x. So first off, we know that x right here is what? 0. That's good, right? X is equal to 0. So I will just put down 0 right here. No problem. And then once we have that, well, we go to here, and what's the right? Remember, we have to go from left to right. So here it will be the curve, and we'll just have to isolate the x right here. So that means x is equal to y squared. So in terms of x, we actually go from 0 to y squared, like so. All right. And then after that, we look at the y. Y is just from bottom to the top, so 0 to 1. And that's it. And in fact, once we change the order, because we're in the x world, integrating this, notice that this function has no x. So this right here is just a constant. So the antiderivative for this, well, let me just put this down again. 0 to 1, the antiderivative of this is just actually x times cosine of y to the third power. And we are in the x world, keep that in mind. So we plug in x is equal to 0, and then x is equal to y squared. And then we have the dy on the whole side here. So put y squared here, we get y squared and then cosine of y to the third power. And thankfully, we have 0. We put 0 here, that's just 0, so that's what we have inside. And then we'll just have to integrate this from 0 to 1 in the y world. And because we're in Calc 3, so this right here should be done in your head. Do a u substitution, then u equal to y to the third power, and then we need 3y squared. Well, it does not have the 3, so we divide it by 3, right? Multiply by 3, divide by 3, so we actually just get 1/3. And then the integral of cosine is positive sign. And then y to the third power. Quick check. If we differentiate this, the derivative of sine is cosine. Use the chain rule, so we multiply by 3y squared. 3 and 1/3 cancel, and we get that. And finally, we'll just have to plug in 0 to 1. Put 1 in here, and guess what? 1 to the third power, just 1, and then we have 1/3 sine of 1. Put 0 in here, that's just 0. Therefore, the answer is 1/3 times sine of 1 for that one. That's it.